Before we get started, remember that we have additional resources available for you. You can find our AI and intelligence community forum. It's available 24/7 for you with articles and content. And this is also the place to go if you want to ask questions about our AI products. To go there is one simple link. It's sn.works/AI. If you are watching that on YouTube, remember that you can subscribe to the ServiceNow Now community channel and get all the latest updates. Before we get started, please take a minute to review our safe harbor statement. And remember to check with your account team whenever you're making a purchase decision to make sure what's available at the time of purchase in the product. A few reminders about the basics of the Academy. So for you, it's fresh ideas. It's great content to better understand and have practical guidance on our product. The session is recorded and then shared on our YouTube channel. If you have friends or colleagues who couldn't attend today, feel free to send them the link to the recording. But since you are here today, you can leverage the Q&A feature to ask all your questions during the session today. And with that, I'm going to hand it over to Sean to get us started.
Terrific. Thank you, Loic. Good morning, good afternoon, good evening, wherever you are. So my name is Sean Hughes. I'm AI Ecosystem Director at ServiceNow. And I'll be stepping you through this morning's session on introduction to ServiceNow research. Joining me is my colleague, Perouz Taslakian, Senior Staff Research Scientist at ServiceNow Research. And with that, Loic, thank you. If you want to get us started. Great, so I'll spend just under 5 minutes going through some background, setting the scene for you. And then we'll move over to Perouz, where we'll dig into scientific AI research at ServiceNow, followed by a brief Q&A. So if you're a ServiceNow customer, you've likely seen this message already. The world works with ServiceNow. And that no matter where work happens, digital workflows drive productivity and great experiences. You're also probably aware that ServiceNow AI powers our intelligent workflows that drive our great experiences. These include onboarding new employees and also processing new customer loan requests, for example, at a bank. But where will work happen in the next 5 years? How can AI be leveraged to optimize and enhance digital workflows? How will productivity be measured in this new future of work? And how will AI-powered automation change our experiences and decision-making? Well, this is where fundamental AI research comes in, and it's one of the ways that we can try and answer these questions. So with that, I'd like to hand over to Perouz. As I mentioned before, Perouz is a research scientist and the research lead of our low data learning program at ServiceNow Research. So Perouz, please take it away.
Thank you, Sean, for the introduction, and thank you, everyone, for being here. It's my pleasure to be here today and tell you more about the work we do at ServiceNow Research. So what I will do in the next 10-15 minutes is give you an overview of the type of things we work on, the different focus areas that we have when we're doing research, and maybe tell you a few research topic examples or papers that we've done in the past. What you'll notice here is that our research is mostly carried collaboratively. We focus a lot on having strong collaborations, both internally at ServiceNow and also across academia with the external partners. And we publish our work in open scientific journals and publications. And this is a part of our core values as researchers in ServiceNow, because in addition to making sure that our work is reproducible and understandable by other researchers, we also want our customers to understand our work to have transparency about how we're doing things in the research space. So what do we do at ServiceNow? What we focus on in ServiceNow is making workflows be smarter. And the way we want to do that is we want to integrate AI so that these workflows are also more efficient. And we want to do all that in a very socially responsible way, at the same time providing transparency and respecting all values that are out there. We also support the global development of knowledge in AI globally through our various partnerships and open source projects that I will give you an overview of. But first, let's talk about who the people are behind the research that takes place at ServiceNow. I will start with our research advisors. Our research advisors are external to ServiceNow who advise us as researchers. So at the forefront, we have Professor Yoshua Bengio, who is, I think, the second most cited computer scientist in the world. He is the winner of the Turing Award, which is like the Nobel Prize for Computer Science for his work in AI. He is a professor at the University of Montreal and is a founder of the Mila Lab, which focuses on machine learning and AI. Next, we have Professor Chris Manning as a research advisor for the Human-Machine Interaction Through Language program, which I will mention in a bit. He is a professor at Stanford and is a very decorated researcher in the area of AI. And we have also Professor Stefano Ermon, who is also a professor at Stanford and is a consultant or an advisor for us at ServiceNow Research. Next, we have our primary fundamental researchers, which conduct research in 3 core areas of research. In the first area that we call programs internally. So the first program is about human-machine interaction through language. This is the group who focuses on language models or modeling language through AI. And so anything about text or language or chatting with machines, this is the group that focuses on that kind of problem. Next, we have the group about human decision support. What this means is that the research happening here focuses on helping the user make better decisions. And we do that by focusing on concepts such as causal reasoning, giving a causality mindset to machines, to AI, trying to get AI to have numeracy, meaning that understand numbers, understand how time series work, be able to predict and forecast time series values, such as, you have a stock value that changes over time, and you want to be able to say something about it in a future point in time. So these are the kind of problems we focus on in this group. And finally, we have the low data learning team. In this program, what we do is we try to find ways to train models, machine learning models, with as little data as possible. Now, as machine learning models get bigger and bigger, and training them becomes very expensive, very time-consuming, and these models are very data hungry, as in you will need a lot of data in general to train them and adjust them to your needs. But there are some things you can do to make that data need smaller in order to reduce your costs and time. And this is the problem that this group focuses on, like how to do something smart in order not to need so much data to train these models, to adjust these models. Okay, so we also have, aside from the research programs, we also have research labs. Now, these are formed on a needs basis. So as soon as we have, let's say in the research group, a technology or a concept that has the potential of transforming into a product, a very wide product, or which is more applied, we spin off a lab, and that lab starts looking into this in a more concrete way. Now, the two labs that we have right now are called AI Trust and Governance Lab, and the second one is the Emerging Technologies Lab. So the AI Trust and Governance inspects and develops all the methods in which we can ensure that the machine learning models we are developing are trustworthy, they are transparent, they do not have that bias, or they minimize the bias, that they are safe to use, and they conform with all the regulations and governance laws that are out there. And this is very important aspect of AI that many tend to ignore, but is at the core of safe AI. And we have a whole lab dedicated to this concept. The second one is Emerging Technologies Lab. This is a lab that specializes in different industries and tries to export the research that we do in the research group to these industries, like banking or manufacturing, and what are the specific things, products that they need, and how do we move the research happening in the fundamental research group to adjust it and move it to applied products in these industries. And of course, we have our research management who undertakes the task of managing the operations of all these research groups, and the researchers and the interns that we have, and the programmers and the infrastructure that we have to run on. So now let me tell you a bit about the quick theme about these groups. So for every group or every program, we can summarize it as the question that this program is working on. So for the human-machine interaction through language, the question we are asking ourselves is, how do we enable ServiceNow users to confidently make the right decision at the right time? So actually, this is the human decision support program. The text is mixed up there. So for human decision support, what we do is we try to enable ServiceNow users to make decisions in the correct way. For the human-machine interaction through language group, what we want to do is to enable the next generation of language interfaces, human and machine language interfaces. For the data learning group, the question is, how do we efficiently train AI models using just a few labeled samples? For trust and governance, we want to de-risk AI for ServiceNow and for our customers, while also adopting or supporting adoption of AI at a very large scale. And finally, emerging technologies, the question here is, how can we demonstrate AI's ability to accelerate these digital transformations? We also have many research partnerships together with other enterprises or mostly academic partners. And here, our goal is to support the global development of knowledge in the AI space. And we also want to make sure that our contributions to ServiceNow are rooted in the most innovative approaches applicable to enterprise AI, which is what we focus on. So to mention some of the projects or the papers that we have put out there. If we can move the slide, yes. So this is a grid of different specific projects or papers or research works that we've done over the past few years, grouped in a theme. Let me touch upon some of them. So one theme deals with model training, and this is about figuring out ways to efficiently train our models, to train them quickly, needing less GPUs, needing less data, etc. So there's a class of papers that we have in this space. We have a whole area of summarization, text summarization, whether you're summarizing a long chat or whether you're summarizing legal documents or very huge huge pieces of text. This is another area. Knowledge synthesis is an area that deals with trying to either complete the missing information in your databases. Let's say if you have a piece of database, it doesn't have to be language. And it also deals with the question of how do I interface my database, my enterprise database, let's say, with a language model that needs to have some concrete information, dig out some concrete information, and in order to answer a question. Text to code is another area where we would like to convert natural language into a piece of code that, in order to help the coder or the user develop its small program. Intent classification with GPT-3 is another project that was done here, and this is trying to classify the intent of the user through natural language again. Reasoning is a whole big area. By reasoning, we mean enabling machine learning models to reason like humans. And currently, many of the language models that we see out there lack this kind of reasoning capability. They look like they understand, but they don't. And there are many techniques that we can develop and integrate into these language models so that they can understand concepts like causality. If you do this, it's going to cause something to happen. And this kind of links and understandings is something that models need to have in order for them to be safe, to be reliable, and to be usable in an enterprise context. There are other, we have a lot of work in computer vision, in generative AI, in generating images from text or other kinds of input. We have work in continual learning, which is about once you have a model that is trained on certain data, how do you keep it updated? How does this model continuously learn as you interact with it? This is not a very simple question, and there are many ways of addressing it, and we do research in this as well. We have applied our research to other settings, such as climate science, where we have some work that computes emissions with machine learning approaches, that tracks climate change through different means, satellite images, etc. Again, all of this using AI. I will dig into some of these projects in a bit more detail. But before I go to that, let me quickly mention about the research impact that we have and how to measure it. So the research we do in the research group, in the fundamental research group, is very cutting edge. Not all research projects make it to publication. Most do, but not all, and even fewer make it into a product. So it is usually a very long process between you have an idea that you want to explore, and this idea is already in a product. There's a very long, maybe 6 months up to 2 years it could take, because what you're doing is very risky kind of investigations. They may or may not work, but if they work, it's going to be great, right? And we constantly push for that. But now we publish our work. Everything we do is you can find on Google Scholar, where if you search for a paper, you will find it and find all the details pertaining to it. We publish code, the code we use to train our models that are in the paper. And one way to find out how impactful a published paper is through its number of citations. How many people, how many other researchers cited this paper? And this is what this slide is showing, that in Google Scholar, it's very easy. There's an easy way to find out how important, let's say, or popular this paper is. And as you can see, one of our papers has 27,000 citations, which is a very big number, given that it's not a too old paper. And our research has, many of our works has a lot of impact and in the research community, in the academic community. And a lot of that also translates or will translate into our products that we provide to our clients. And if we go to the next slide, this is just an overview of the most important papers we've shown during the year, and you can take a look at it if you'd like. Yeah. Okay, so let me just quickly give some spotlights, some projects. I have selected 6 featured research projects here, and we have many, many more, but let me just go through some of these. The first one is Fashion Gen. It's one of my favorites, personally. Fashion Gen was a project we did a few years ago, which was about generating images from text. So we had we collaborated with a company that sells fashion items like clothing, high-end clothing, and they provided us with a data set of pictures of this clothing with text descriptions of the clothing. And we designed a model that, given a text, a description of a piece of cloth, it would generate the picture that's your description, and that matches your description. And we had a whole competition around it, and many people participated in this project. We also did other things with this data set, like recommending pieces of clothing that you should buy that match with what you already have based on your wardrobe. And this was a recommender system. And this was one of the projects that had a lot of impact at the time. We have a project that was recently published, actually, called Tactis. This is a time series related project. This means that this is a project whereby if you give this model a huge number of time series, let's say a bunch of stocks with their value over the past 3 months, it will be able to forecast the value of one of these stocks at a future point in time. And this model had a lot of accuracy. It's a very huge model, which has the potential of being transformed into a foundational time series model, if you'd like, that understands time series and how time series work. This was recently published at ICML. Now, the next one is Tapioca. Tapioca is a project about conversations, about interacting with an AI interface. It addresses a particular aspect of chatting with an AI interface, which is about switching context. When you chat with a machine and you have a certain theme or a topic you're talking about, you sometimes would switch context and start talking about something else. That's the natural way of conversation goes. And language models sometimes are not good at that context switching. And this was a project that was dealing with that aspect of chatbots and had a model that would address that in a successful way. Picard is text to SQL project. SQL is the language of databases where you, in order to query a database, you usually need to know SQL language. And Picard is a model that, given a natural language question, would translate that to an SQL query sentence based on the database schema of your own database. And this would enable users to query their database without having to actually know how to construct very complex SQL statements. Azimuth is a project that is for machine learning researchers. It's a project that helps machine learning researchers or practitioners better understand their data sets, better model predictions, doing error analysis with a very nice visual interface. This is an open source project. It's up there for anyone to use. And it does many things like semantic similarity analysis and saliency maps and all the tools you need as an AI practitioner to explore your data. And finally, we have BigCode, which is our biggest project yet in this space, and it's the most recent one as well. BigCode is a collaboration between ServiceNow and Hugging Face. It was announced in September last year, a few months ago. And it was a collaboration among more than 500 researchers from 30 countries. And what we put forward is a language model that converts natural language to code. This is a foundational model, meaning that you can build on top of that your specific needs, train it to your specific domain. And the model itself is called Santa Coder. It has 1 billion parameters. And the important thing about this project is that it is done in a very transparent way, in a responsible way. Instead of training on everything that we could find online, we asked users to, gave the users the option to opt out of getting their code being used as training data set. The model itself, it outperforms many of the large models out there. And it is a very good start as a collaborative, open, responsible foundation model, which we believe should be the way that businesses should do modeling, AI modeling within their companies. So I'm running out of time. So let me just quickly say that the future of AI, I see it as very exciting. It has the potential to affect us on all personal, enterprise, and at the humanity level. For the personal level, I would imagine having a cognitive buddy with me all the time, giving me advice on various things that I would like to know about. From an enterprise automation perspective, it has a lot of potential to automate a lot of the works that enterprises need automation for. And finally, its impact on drug discovery will be huge in the future. That's something I am personally very interested in, and on the effect on how we understand climate, how we track climate change, and how maybe we can deal with it and make the correct decision at the right time to counter it. So I'm going to hand it over to Sean for some parting thoughts.
Thank you. That was great. I hope everyone found that insightful and valuable. And I know we covered a lot of ground in Perouz's session. There's so much to talk about. We do look forward to having follow-up sessions. So do feel free to put into the chat the parts of the presentation you found most interesting. Perhaps if there was something that was thought-provoking for you that you learned about today that you'd like to know more about, let's see if we can try and address that for you. We're going to encourage you to visit our ServiceNow research website. This is on servicenow.com/research. You can also follow us on LinkedIn and Twitter, ServiceNow Research on LinkedIn, and at ServiceNow RSRCH on Twitter. And on Twitter, you'll find probably the most current real-time news and see our responses to the community. Everything is done very visibly. Just a point to note on the BigCode project, it is an open science collaboration. It is active today. Anybody in the world is able to go and visit the BigCode project, and if they have a research interest, if they have an interest in trust and governance for large language models and want to help shape the future of where we go with this, the collaboration is open. So there is a form where you can request to join, and anyone who does join, really it is a research project, so there is a little bit of screening up front just to make sure that researchers are first and foremost the ones participating. But we also do welcome practitioners and even legal teams to join our legal ethics governance working group within the project. This way, you can participate in the dialogue. And what's more, all of the models, data sets, model cards, data cards, code to reproduce, results from experiments from Big Code Project, they're all published in open source. So as was mentioned by Perouz, we've actually got the attention of the European Parliament's Innovation Lab, and they've actually requested us to meet with them just to explain, what we're doing, because they've been following the project, and for them, this is a model of how open science should be done. So, encourage you to check that out. And with that, Loic, thank you very much for hosting us.
Thank you. Just before we go, we have one quick question. Somebody was asking if there is a specific group amongst the group that we presented that is working on for example, the AI search feature. Would you say it's shared and it's a collaborative effort that then leads to new products?
Sure.
Our fundamental research scientists, they focus on the long-term 5-year plus type research. One of the teams that Perouz spoke about was the Emerging Technology Lab, as well as the AI Trust and Governance Lab. So our Emerging Technology Lab is mostly comprised of applied research scientists, whereas the other researchers are fundamental research scientists. And the applied research scientists, they take our research, they package it up into proof of concept applications, they really dig into it to try and fully understand it. And then they have a very close working relationship with all of the product teams that are developing ServiceNow capabilities like AI search. And so you'll see that all the research that was presented, there's bits and pieces of it that apply to different modules, different AI-powered modules across ServiceNow. So through our Emerging Technologies Lab, we do work closely with the AI search team, but it's no one particular person. It really depends on what is the question, what is the problem that the AI search team is getting as a big hard rock from our customer base, and then is there anything from ServiceNow research that is potentially relevant to tackling that project.
Yeah, thank you very much for the answer. So thank you for the both of us to presenting today, and it was great to show the benefit of having an open science, open governance approach, and how it's gonna increase the ROI for our customers using the ServiceNow platform.
Thanks, Loic.
Thank you.
Thanks, everyone.